Hello lovelies, in this video the brilliant Mr. B is going to be looking at the area between curves, working out the area between curves for you. Now there are lots of examples at 3 different levels worked through slowly in this video, so you can pause it, rewind it, jump in wherever you want to, not having to worry about what the person sitting next to you is thinking or what the teacher over there is saying. If you want to follow this up with lots more practice questions with worked examples to show you where you might go wrong, then over on my website there is a massive course and workbooks just waiting for you.
Integration is about finding the area between a line or curve and the x-axis. Now, what we're going to do in these questions is find the area between 2 lines. And they can be straight lines or they can be curves. Now, the way that we do this, the key to it lies in how you write out a line or a curve. So we've got the curve y equals, and then we have x squared minus 15x plus 56. Now, the line, that's also a y equals, and it's negative x plus 8. That means that both the line and the curve are equal to y. And if they're both equal to y, that means they can also be equal to each other. And this is our first step. So we write x squared minus 15x plus 56 is equal to, now it's equal to y, and what's also equal to y is a negative x plus 8. We can then collect like terms. So if we work on the left-hand side, we've got the x squared. We can add x to both sides to get negative 14x. We can take away 8 from both sides to get a positive 48. And then what we can do with this is we can integrate this. We can integrate the combined version of both lines. And if we do that, we are going to get the area between the lines. So now we're going to write out the integral. The integral of x squared minus 14x plus 48. And so this is the part where we integrate. So we need to raise the powers. X squared is going to become x cubed. But if you increase the power, then you have to divide by the new power. So we need to divide by 3. 14x, the x is going to go up to x squared. We have to divide by 2 then. 14 divided by 2 is 7. And then the 48, we raise the x. There is no x, it's going to become x to the power of 1. And we divide by 1, nothing changes. So it'll be 48x. So that is an integrated version, our integral. Also remember, we have the plus c when you integrate. So now we have an expression for the area between the lines. We don't actually have the value. So how do we find the value? Well, we're going to find a definite integral, and it's going to be in between the x-coordinates, because the x-coordinates are really kind of where this area is. So we have a look at our diagram. At x equals 6, we've got the start of where the area is, and at x equals 8, we've got the end of where the area is. As you can see, the points where our line and curve intersect represent the start and end of the overlap. So what I want to do now is integrate this between 8 and 6. So if it's a definite integral, start off the largest one, the 8. So we want 1/3 of x, which we're now going to say is 8, and that's cubed. We're taking away 7 lots of x, which is now 8. And we're adding on 48 lots of 8. Now, you might remember from these, you don't need the plus c, because our next step is to take away the same substitution, but using a 6 instead. And so you have a c in the first bracket, and a minus c in the second, and they're going to cancel out. The second bracket, we're going to have 1/3 of 6 cubed, take away 7 lots of 6 squared, plus 48 lots of 6. So now all we need to do is work out each term one at a time. So if you type in your calculator, 8 cubed, and then you divide it by 3, you should get 170 and 2/3. If you 8 squared and multiply it by 7, you're going to get 448. And if you do 48 times 8, you're going to get 384. Now remember, for the next bracket we're taking away, so we need to flip the sign of anything that we get. So 6 cubed divided by 3 will give you 72. But remember, we're taking away, so it'll be a negative 72. 6 squared multiplied by 7 gives you a positive 252. Now there's a negative on the 7, and we're taking away, that's a double negative, so it is going to stay positive. So be very, very careful with double negatives here. Then 48 times 6 is 288. But remember, we're taking away the second bracket, so we need to take away the 288. If you put all of that into your calculator altogether, then the answer you're going to get is quite interesting. It's going to be a negative number. It's going to be negative 1 1/3. Now, with a negative number, we're finding an area, and you can't really have a negative area. So what we can do here is we can safely ignore the negative symbol. And so we can say that the area between the curves is 1 1/3. Last thing, if you have a look at the diagram, let's see if this is reasonable. Now we can see we've got a full half in the area I'm highlighting in purple on the diagram. We've got nearly another half next to it. It's a little bit less than a half, but we can see we've got the little bit of the curve at the bottom as well. So together we can imagine what we've highlighted in purple is 1. And then we've got a little bit extra. So is it credible that this shaded area could be 1 1/3? Well, I think it is. It looks pretty close. Now, if we get an answer like 10 or something like that, or 0.1, then we would know that we had the wrong answer and we need to look back for a mistake. So let's recap the method with our next example. So we have y is equal to 4x squared minus 26x plus 42, and y is also equal to x plus 4. So we can make the two lines equal to each other. We've got one line and one curve. Collect all the like terms, so we can take x away from both sides. So the squared part will stay the same, but we take away another x, or negative 27x. We want to take 4 away from both sides. That will give us plus 38. And now we collect everything onto one side. We can integrate. So we're going to integrate 4x squared minus 27x plus 38. So we want to increase the power of each term. So x squared will become x cubed, but we need to divide by that new power. So the 4 will be divided by 3. We're at negative 27, so the x is going to become x squared, and we're going to divide the 27 by the new power, the 2. And 38 will become 38x, and as usual, the plus c after you integrate. So now we've got that, we can now try and find the area under that line. Now, if we look at where the line of the curve intersect, you might be given this, you might be not. If you're not given it, you'll be given the diagram. So we're in between 2. And again, we can see that if x equals 2, see this is the start of the shaded area. And then we want to go up to 4 3/4. And again, we'll look at 4 3/4, just before 5. If we look up, we can see that's the end of the shaded area. So it makes sense to go in between 2 and 4 3/4. So now we need to substitute the largest value first, which is the 4 3/4. So every time we write down x, we're going to swap it with a 4 3/4. So we've got 4 over 3. Then we've got x, 4 3/4, and then we're cubing. Then taking away 27 divided by 2 multiplied by x, 4 3/4 squared, and then we're adding on 38 multiplied by 4 3/4, which was x. We can ignore the c because we're going to take that c away when we get to the next bracket. So it's going to cancellate anyway. The next bracket is the same thing, but we're going to substitute in 2. So the same for thirds. X is 2, and it's cubed. And again, just writing out the whole thing. Every time we come across an x, we replace it with a 2. And now we've done that, we can type it into our calculator. So 4 3/4, you could write 4.75. We're going to cube it. And then we're going to multiply it by 4, divide it by 3 for the fraction. And altogether, we get quite a tricky number actually. We're going to get 142.89. Let's say 896 to 3 decimal places, and we'll round to 1 decimal place at the end. Then we've got 4.75 squared, multiply it by 27, divide it by 2, and we are taking away 304.594 to 3 decimal places. Then we have 38 multiplied by 4.75, and that gives us 180.5. So that's our first bracket. Let's have a look at the second bracket now. So again, we've got 2 for this one. Cube it, multiplied by 4, divided by 3. And we get, altogether, we're going to be taking away this one. Take away 10. And it's 10 and 2/3. So we could write 667 to 3 decimal places. Then we've got 2 squared, multiplied by 27, divided by 2. And that's 54. Now we're taking away that in the second bracket, but we're taking away the entire second bracket. That's a double negative. So we're adding on 54. Then we have 38 times 2. And again, we're taking this away, so it's take away 76. So now we need to add all this up on our calculators to get our final answer. That should give you negative 13.9. And as usual, with a negative area, we can safely know you can't have a negative area. So I'm going to say the area is 13.9. Now, again, you might want to have a quick look at the diagram at the end, just to get an idea of, does this make sense? Now, this is a larger area than before, so I think 13.9 looks like it's more credible. For the next question, we have y equals, we've got half of x squared, take away 5/2 of x, plus 2, and that's equal to y. And what's also equal to y is negative x plus 4. We make them equal to each other. I'm going to collect up like terms. This is going to give us a half x squared. Now looking at the x terms, I'm going to add x to both sides. And you can think of x as being, it's a whole one, so that could be 2 halves. So we add 2 halves onto negative 5 halves. We get negative 3 halves. Then look at the number, we've got a plus 4. Take 4 away from both sides, and that'll give us negative 2. So we want to integrate a half x squared minus 3 halves x minus 2. So increase the powers on the x. X squared becomes x cubed, and we need to divide by 3. Well, we're already dividing by 2, so 2 times 3 is 6. Divided by 6 altogether. Then the next x will become x squared, and again we're going to divide by that 2. So 3 over 2 becomes 3 over 4. Again, if you want to divide by something, it's already got a denominator. Just multiply what you're dividing by that denominator. Then we have got the negative 2, so that'll become negative 2x. So now we've got an expression for the combined lines together. If we find the area under that line, it will be the same as the area between the 2 lines we were originally given. Now we're substituting in between 4 and negative 1. So just notice we're only looking at the x coordinates here. We don't care about the y coordinates. So substitute the largest one first. That's a positive 4. That's going to give us a 6th of 4 cubed. Take away 3/4 of 4 squared. Take away 2 lots of 4. We're taking away from that a second substitution. That's the negative 1. So that's a 6th of negative 1 cubed. Take away 3/4 of negative 1 squared. Take away 2 multiplied by negative 1. And again, if we work this out, we are going to get the area under the curve. So we have 4 cubed divided by 6, which will give us 10 and 2/3. We have 4 squared, and then we want 3/4 of it, so we can times by 3, divide by 4. That'll give us 12, so it's take away 12, and then 2 times 4 is going to give us 8. We're going to take away the second bracket. Now, because let's put negative 1 in brackets, and then cube it, and we should get negative 1. And so negative 1 times the 6th is negative 1/6. We're taking that away, double take away, so it's actually going to be adding 1/6. Then we've got negative 1 squared, which is positive 1, multiplied by 3/4 is 3/4. Now it's a negative 3/4, and we're taking it away. So again, we've got another double negative, so we're adding 3/4. And then negative 2 times negative 1 is positive 2, but we're taking it away, so that'll be negative 2 altogether. So we can add all of that up. Altogether, to 1 decimal place, that'll give negative 10.4. We're adding a final answer for the area. Area is going to be positive, so the area will be a positive 10.4. Now, again, at the end, have a look at the area you've got on the diagram. It looks like a decent size. It's not really small. It's not really big. So 10 looks like it could be the right answer. Next, we have x squared plus x minus 2. That's equal to y. And what's also equal to y is negative x, take away 2. So bring everything to one side. We only have one x squared term, but look at the x terms. We need to add x to both sides to get it away from the right-hand side. That'll be plus 2x. Then we need to add 2 to both sides to get rid of the minus 2 on the left. And that's actually going to give us 0 on both sides for normal numbers. So we are integrating x squared plus 2x. Increase the power of the x to a 3, but we have to divide by 3. And increase the power of the x to x squared, but we have to divide by 2. Now the coefficient's already a 2, so 2 divided by 2 is 1. Then we just need to add c at the end. So we've got our expression for the area between the curves. Now we just need to substitute. What are we substituting? Our x coordinates, 0 and negative 2. Now with 0, there's a nice shortcut you can take here with 0. And it's basically that, we're going to have x squared plus 2x, and we're substituting x for 0. Now, if every single term has got an x in it, then we know the answer is going to be 0. Now, we could write, well, a third of 0 cubed plus 0 squared. But since everything's got a 0 in it, it's being multiplied by 0, we know 0 is going to be the answer. So for more complicated substitutions, you can actually skip doing the substitution for all the x terms, because you know it'll be 0. Do you look out for any whole number terms though, because that won't be 0. Next, we're substituting negative 2. So this time we do have to write it out properly. So negative third multiplied by negative 2 cubed plus negative 2 squared. So we can work that out. So negative 2 cubed will be negative 8, and divide it by 3. And it'll give us negative 2 and 2/3. But remember, we take away that second bracket, so it'll actually be double negative, and we'll be adding 2 and 2/3. Then we have negative 2 squared. Negative 2 squared is going to give us 4. Remember, take away the second bracket, so we need to take away 4. So altogether, that's going to give us a negative 1 1/3. Now, we know for the final area, we don't need to write down the negative because you can't have a negative area. And we can also, we did know the previous questions to 1 decimal place. So this would be 1.3 to 1 decimal place, or 1.33 to 2 decimal places. Now, if the question is asking decimal places, that's fine. If it's not, then just leave it as a fraction, because that's more accurate. The next question, we have y is equal to 2x squared minus 20x plus 48, and that's equal to x minus 1, because both sides are equal to y, so they can be equal to each other. And then combine like terms. The x term, take x away from both sides, and for the number term, add 1 to both sides. And then everything is on the left-hand side, and we can integrate it. So we're integrating 2x squared minus 21x plus 29. So we increase all the powers. X squared becomes x cubed, but we need to divide by 3. X becomes x squared, but we need to divide by 2. And 49 becomes 49x. At the end, we have plus c as always. So now we have our expression that shows the area between the two curves. Now we just want the value. We're substituting in our 2x coordinates of where the two lines intersect. 3.5 and 7. So let's start with a 7. So it's going to be 2/3 of 7 cubed minus 21 over 2 lots of 7 squared plus 49 lots of 7. Taken away from that, we're going to substitute in 3.5. So that's going to be 2/3 of 3.5 cubed. Take away 21 over 2, 3/2 squared, plus 49 lots of 3/2. So we can work out each one of these one at a time. So 7 cubed, then times by 2 divided by 3 for the fraction. That's going to give 228 and 2/3. 7 squared multiplied by 21 divided by 2. That's going to give us 514.5. We could be consistent and use fractions here and say a half. Then we've got 49 times 7, which is 343. So that's our positive side done. Now let's do the negative side. So we're going to have 3.5, let's say 3.5, cubed, times 2 divided by 3. Now this is going to give us 28.583, so 3 decimal places. And that's positive, but we're taking away this side, so we're going to make it negative. Then we've got 3.5 squared, multiplied by 21 divided by 2. And that's going to give us 128.625. Now, this is a negative anyway to start with, and we have to take it away. So it'll be double negative, so we're adding it. Finally, we've got 3.5 multiplied by 49. That's going to give us 171.5. Now that's positive, but we're taking away this side, so this will now be a negative. So now we've got these, we can add them all up. So altogether, that gives us negative 14.3 to 1 decimal place, which means that the area is going to be 14.3, because again, we can't have a negative area. Now the next set of questions look more complicated. For the easy questions, we had the area between a line and a curve. Now we're looking at the area between two curves. But these are still technical lines, just a different kind of line, and it's going to work exactly the same way. So let's have a look at it. So our first curve is a half x squared plus a half x minus 3. Now that's equal to y, and y is also equal to negative x squared minus 4x minus 3. So we're going to collect all the terms to one side. Now the right hand side is all negative, so we add it all, then everything will be collected on the left hand side. So we can add x squared to both sides, giving us 1.5 x squared. We can add 4x to both sides, giving us 4.5x. And we can add 3 to both sides, which will give us 0. And now we have that, we can integrate it. So we're integrating 1.5 x squared plus 4.5x. So we need to increase the powers. X squared will become x cubed, and we want to then divide by 3. Now 1.5 over 3, well 1.5 is half of 3, so that's actually going to be a half altogether. Then we're going to have the x is going to become x squared, and we have to divide 4.5 by 2. So 4 divided by 2 is 2, and a half divided by 2 is a quarter. So we've got 2.25 x squared. And we have the plus c. So we have our expression that shows the area between the lines. We just need to substitute. I'm going to substitute in between our x coordinates of where the two curves intersect. That's 0 and negative 3. So first we're going to substitute in 0. Now we can see that both of our terms have x in them, so we know this is going to give us 0 altogether. So there's no need to look at it. Then we're going to substitute in negative 3. So we're going to have half of negative 3 cubed plus 2.25 lots of negative 3 squared. So working this out, of course, we've got 0. Then we've got negative 3 cubed is going to be negative 27, and we want half of that. So half of negative 27 is going to give us a negative 13.5. However, we want to take it away, and it's already negative. So a double negative gives us a positive. Then we have negative 3 squared, which will be 9. And we want to times it by 2.25. So we times it by 2.25. That's going to give us 20.25. And this is going to be positive, but we're taking away the second bracket. So we're going to take it away. So if we add these together, we are going to get negative 6.75. So when we write down the area is going to be a positive 6.8 to 1 decimal place. You could write it as a fraction as well. You could write 6 3/4, so it's fully accurate. And honestly, 2 decimal places would be fine as well, 6.75, if it's just asking for the area between the lines. But always pay attention. It might ask for 1 decimal place, which is what my answer is. It might ask for 2 decimal places, or it might ask for an accurate answer with a fraction. So keep an eye out for it. The next example, we have y is equal to x squared plus 10x plus 24. That's equal to y, which is also equal to negative x squared minus 8x minus 12. Now you'll notice that one side's positive, one's negative. That's quite common because it's easy to get them to cross over and have an area between them in that way. You can have them both positive as well, but this is the easiest way to do it. So let's get everything to one side. So we're going to add on the negative side. We're going to add x squared to both sides. We're going to add 8 to both sides. And then we're going to add 12 to both sides. That gives us the expression we're integrating, which is 2x squared plus 18x plus 36. So increase the powers by 1. X squared becomes x cubed, but we have to divide by the 3. Then the x becomes x squared. We have to divide by the 2. 18 divided by 2 is going to give us 9. Then we have the 36, which becomes 36x. And now we have the expression that we need to substitute into. We're going to substitute into negative 3 and negative 6. Substitute into the x coordinates of where the two lines intersect. Start the largest one, which is negative 3. So this one might be a little bit complicated. We've got 2/3 of negative 3 cubed plus 9 lots of negative 3 squared plus 36 lots of negative 3. Taken away from that, our substitution of negative 6. So that'll be 2/3 of negative 6 cubed plus 9 lots of negative 6 squared plus 36 lots of negative 6. So the next step is to work out all these values and see what we have for the area. So negative 3 cubed is negative 27. We want 2/3 of it times by 2 divided by 3, and that will give us negative 18. Negative 3 squared is 9, and 9 times 9 is 81. And then 36 times negative 3 is going to give us negative 108. So that's the left-hand side done. Let's do the right-hand side bracket. So negative 6 cubed is going to give us negative 216. Want 2/3 of it times by 2 divided by 3, and it gives us negative 144, but we want to take away the second bracket. It'll be double negative, so we're adding 144. Then negative 6 squared is 36 times by 9. We get 324. Now that's positive, but we want to take away this side, so it'll become a negative. Then we've got 36 times negative 6, which gives us negative 216. Again, we're taking this away, a double negative will give us a positive. So now we can add all of these up, and the answer we should get is 9. Now that is actually going to be a negative 9, but when we write down the area, we only want the positive version of it. So the area is 9 in between the two curves. Our next two curves are 2x squared plus 18x plus 36 and negative x squared minus 12x minus 36. So let's collect everything onto the left-hand side. Let's add x squared to both sides, giving us 3x squared. Let's add 12x to both sides, giving us 30x. And let's add 36 to both sides, giving us 72. So we need to integrate that, increase the powers. X squared becomes x cubed. And then we need to do 3 divided by 3, which will leave us just 1x cubed. Then we have a 30x, increase the power by 1 to x squared, and divide by 2. 30 divided by 2 is 15. Then the 72 becomes 72x, and we have the usual plus c. So now we have the expression we're going to substitute into. Check what we're substituting. We're substituting negative 4 and negative 6. So we'll do the negative 4 first, and that's the largest of the two. That's going to be negative 4 cubed plus 15 lots of negative 4 squared plus 72 lots of negative 4. Take away. Our second substitution is a smaller one, negative 6. That's going to be negative 6 cubed plus 15 lots of negative 6 squared, 72 lots of negative 6. So negative 4 cubed is going to give us negative 64. Negative 4 squared times by 15 is going to give us 240, and 72 multiplied by negative 4 is going to give us negative 288. So we're taking away the second section. So we're going to have negative 6 cubed, which is going to give us negative 216. However, we have to take that away. That'll be a double negative, which will make it positive. Then we have negative 6 squared multiplied by 15, which is going to give us 540. And that's positive. We're taking away the second bracket, so that'll be a negative 540. Then 72 times negative 6 is going to give us a negative 432, but we're taking that away. Double negative means we're adding it. So if we add all of that up, then we should get negative 4. And so the area is going to be 4 altogether, because again, we're not going to have a negative area. Next, we have x squared minus 5x plus 4 for our first curve, and negative x squared plus 2x plus 8 for our second curve. So gathering it all on one side, we can add x squared to both sides. We can take away 2x from both sides, and we can take away 8 from both sides. That means we are integrating 2x squared minus 7x minus 4. Integrate, we need to increase the powers. X squared becomes x cubed, but divide by the 3. X becomes x squared, but we need to divide by the 2. And 4 becomes 4x. So now we need to substitute into our new expression. I'm going to substitute in the x coordinates 4 and negative half. Start with the larger one, which is the 4, giving us 2/3 of 4 cubed. Take away 7/2 of 4 squared minus 4 times 4. Then we substitute for the second bracket, which is negative half. So we have 2/3 of negative half cubed plus 7/2 of negative half squared. Take away 4 times negative half. So again, if we find out all the values of these, then we're going to have our area. So 4 cubed, we want 2/3 times 2 divided by 3. That's going to give us 42 and 2/3. Then 4 squared, we want 7/2 of it, so times by 7 divided by 2. That's going to give us 56. And then negative 4 times 4 is negative 16. Moving on to the second bracket, so negative half, negative 0.5 will do. And if we cube it, we're going to get negative 0.25. We want 2/3 of it, times by 2, divide by 3. And that's going to give us a negative 0.083 recurring. And that's negative. We want to take this away, so it's going to be a double negative. Now, I've got a mix of fractions and decimals in this, so write it in whatever form you prefer. Try and be consistent if you can. If it's non-calculator, then you can do this by keeping everything as fractions. If it's calculator, then it doesn't matter too much. You can work it out at the end. Next, we've got negative 0.5 squared, which is going to give us a positive 0.25. We want 7/2 of it, times 7, divide by 2. And that's going to give us, it's already negative, and it's 0.875. We want to take it away, which will give us a double negative. Then for the last one, we have negative 4 times negative 1/2. So half of 4 is 2. And we need to take it away, so it's going to be a negative 2. So if we add all of that together, then we should get negative 30.375. So the area to one decimal place is going to be 30.4. The last medium question is x squared plus 4x plus 3 equals negative x squared minus 2x plus 3. So collecting all the terms, we can add x squared to both sides. We can add 2x to both sides. And we can take away 3 from both sides. That means that we need to integrate 2x squared plus 6x. So we increase the powers by 1, x squared becomes x cubed, but we divide by the 3. And then x becomes x squared, and we divide by the 2. 6 divided by 2 is 3. So we're going to substitute, and we have 0 and negative 3 to substitute. So the largest one of these is 0, but we know that when we substitute in 0, both terms have got x in. So we're multiplying by 0 both ways, so you need to look at the first bracket. It is going to give us 0. We don't need to focus on the second bracket. So we are taking away the negative 3. So that will be 2/3 of negative 3 cubed plus 3 multiplied by negative 3 squared. We can work that out. So negative 3 cubed is negative 27. We want 2/3 of it, times by 3, divided by 2. That will give us negative 18. And we're taking it away, so double negative will be a positive. Then we have negative 3 squared, which is 9. 9 times 3 is going to give us 27. That's a positive 27, and we're taking away the second bracket, so that'll be a negative 27 altogether. So 18, take away 27, will give us negative 9. So we know the area between the two curves is going to be 9. Now, to change the hard questions, we're going to find the area between a cubic and a quadratic. And if you look at the curve, you'll see there's actually 2 shaded sections. Now, I'm going to start off the same way, but there are going to be changes when we have to look at those 2 shaded sections. Now, I'm going to need some more space working out here, so I'm going to try and compress some of our working out lines here. So we're going to start off with our integration. Now, we know that these 2 lines are going to be equal to each other. We only have one that's got an x cubed, so we're going to write that in. Look at the x squared. We've got 14x squared. But we'd have to take away x squared. That would give us 13x squared. Then looking at x, we've got 61x, and we take away 11 from it, giving us 50x. And then we've got 84. We'd have to take away the 28. And so that's going to give us 56. So we've got the expression we need to integrate. If that's too much all at once, then just go back to how we did it in the previous slides and just think about just doing it more step by step until you get this answer. So now we can integrate it. So we're going to increase the powers. So x cubed is going to become x to the power of 4, but we need to divide by our new power. Then x squared is going to become x cubed, and we have to divide by a new power, so 13 will be divided by 3. With 50x, the x is going to become x squared, and then 50 divided by 2 is 25. And the 56 will become 56x. So it's a substitution with this that gets interesting. Now we have 3 values of x to substitute. We've got negative 2, negative 4, and negative 7. So what do these mean? Well, if we look at negative 2, we can see when x is negative 2, that's the end of our shaded area. When x is negative 7, that's the start of our shaded area. So you might think, well, do we substitute in between negative 7 and negative 2? Well, no, we need to take the negative 4 into account as well. Now that is where the 2 shaded sections are separated. So what we have to do is we have to substitute separately for each area. We do a substitution for the first area and then a substitution for the second area. So looking at area 1 first, what we need to do is look at the numbers for area 1, and that was the negative 7 and the negative 4. So we're going to substitute in negative 4, giving us a quarter of negative 4 to the power of 4, plus 13/3 of negative 4 cubed, plus 25 lots of negative 4 squared, plus 56 lots of negative 4. So a lot of work to do here, but this will be worth a lot of marks. And then we need to take away our second substitution, which is going to be negative 7. So we'd have a quarter multiplied by negative 7 to the power of 4, plus 13 lots of 3, negative 7 to the power of 3, plus 25 lots of negative 7 to the power of 2, plus 56 lots of negative 7. So again, we can see there's quite a lot going on here. So we'll get the value for that, And then we look at the second area. And for the second area, we're going to substitute in the two pairs of that. So we've got -4 and -2. So we substitute -2 in first. Yeah, it's exactly the same process. And then we take away our second substitution, which would be -4. Now, I am going to write this down again, but we've already found -4 from our very first substitution for the first area. So you should have the value for that already once you get to this point. But I'll write it down for completeness. And then what you do is, all we have to do simply is add together area 1 and area 2. And that should give the total area that's shaded in between the two curves. So basically, when you've got a cubic and a quadratic and you have two shaded areas, it just means you're doing twice as much substitution. Although one of them you've done already, so really you're just doing 3 substitutions rather than 2. Now, at this point, we should know how to substitute. I've recapped it enough, so I'm just going to give you the answer. So if you do all of this, you should get 21.1 to 1 decimal place. So again, make sure you get the area 1, which is taking away the 2 substitutions, -4 and -7, and then add to that area 2, where you still take away the 2 substitutions, this time -2 and -4. So I would get a value for all 4 brackets, and then I would take away the ones for 1 and 2, and then add together the final answers at the end. So let's go through another example. So we're going to take the bottom curve away from the top curve. So looking at the top curve, we've got -x cubed. That's the only cube term we've got. Then we look at the x squared. We've got 17x squared, and we're going to take away x squared. That's going to be 16x squared. Then we've got -90x, and we're going to add 11 to it. So -90 plus 11 is going to give us -79x. Then we've got 144, and we're going to take away 24 from it. That's going to give us 120. And this is what we want to integrate. So we need to increase all the powers by 1. Cube becomes power 4, but divide by the 4. Squared becomes cubed, but divide by the 3. X becomes x squared, but divide by the 2. And numbers become x. And remember the plus c on the end. Even though we're not using it in these questions, it's mathematically correct to include it. We'll look at the diagram to understand these substitutions. We've got 8, 5, and 3 as our x coordinates, because we've got 3 places where the 2 curves intersect. We've got 2 areas. Let's label them 1 and 2. Area 1 is in between the 3 and the 5. So we're going to look at that one first. Now, I'm not going to write out the entire thing now, so you'll be used to how it works. So you're going to substitute in the larger value, which is the 5. You're going to take away from the smaller value, which is the 3. And that's going to give you the area of curve 1. Then for curve 2 is in between the substitution of 5 and 8. So we start out with the largest one, the 8, and we do the substitution for 8. So this will be new. But then we take away the substitution for 5. We've already done that for the first question. So you should already have that number. If you take those away, you're going to get the area of 2. So when you do this, don't worry when you're substituting in the second bracket, doing the double negatives. Get the answer for just the first bracket, the answer for just the second bracket, get those 2 individual numbers, then take away. That way you can reuse, for this example, a substitution for 5, and only do 3 lots of substitutions. At the end, add together curve 1 and curve 2 together, and that's going to give you the final answer. And for this one, it's going to be 21.1 again. That's the area between the 2 curves, including section 1 and section 2. Moving on to the next example. So again, we're going to take the 2 lines away from each other to combine them together. We'll use the top one as our base. So we have -x cubed. That's our only x cubed term. And we're going to write this down as an integration. So then looking at the x squared term, we've got -19. Then we take away 1 more. So that'll be -20x squared. Then we've got -116. And we are going to take away 11. That'll give us -127x. Then we've got -224. And we're taking away 28. which will give us a negative 252. Now, you'll notice all these are negative. Now, if you prefer, you could take away the other way around. So you could use the x squared plus 11x plus 28 in the same way we used the left-hand side in the previous questions, and then take the top away from that. And we'll end up with all positive values. What you'll find, though, is that either way, you are going to get exactly the same answers at the end. So now we're going to integrate. So we're increasing all the powers by 1. 3 becomes 4, but we have to divide by 4. 2 becomes 3, but we need to divide by 3. 1 becomes 2, but we need to divide by 2. And there's nothing there at all. Then we can put the x on. So that is our expression for what's in between the two curves. We just need to substitute the right values. So we have negative 4, negative 7, and negative 9. We've got section 1 and section 2 of our area. So doing section 1 first, we're going to substitute the largest value on section 1. Now it's in between negative 9 and negative 7. So negative 7 is the larger of the two. We're substituting negative 7. We're going to take away the substitution for negative 9. Again, we've gone through how to substitute in previous questions. There's no need to repeat it. And that should give you area 1. Area 2 is in between negative 7 and negative 4. Negative 4 is the largest of the two. And we're going to take away negative 7 from it, which you should already have. That's going to give us area 2. Add your two answers together, and that should give you the area between the two curves. And that should be, again, it's 21.1 for this question. Just a coincidence that the last three have been 21.1. The next two are going to be different. So, following our method for the next example, so first we need to work out what we are integrating. So we can take the two curves away from each other. We've only got one x cubed term. Then we've got negative 11x squared. We need to take away another x squared. We've got 34x. I'm going to take away a negative 10. I'll be adding 10 instead. It's double negative. Then we've got negative 24. And we take away 24. That's going to give us 0. So to integrate, we're going to increase all the powers by 1. 3 becomes 4. Divide by 4. 2 becomes 3. Divide by 3. And 12 divided by 3 is 4. Sometimes we get a whole number out of it. X becomes x squared. 44 divided by 2 is going to give us 22. And as usual, we need the plus c. So then we need to substitute. Now we've got 4, 6, and 2. So look at your curve. Label your first and second areas. The first one is in between 2 and 4. So substituting the largest one of those two, which is the 4. Now again, you can do the substitution. Take away the substitution for 2, and that's the area for 1. We want the area for 2. That's in between 4 and 6. The largest one is 6. Substitute that first. You should already know the answer for 4. Take that away second, and that'll give you the area for 2. Add those two areas together, and for this question, you should get exactly 8. So now look at the final question. Again, take the curves away from each other, and we want to integrate. We've got negative x cubed. We've got negative 9x squared. We'll take away another x squared. Negative 10x squared. We have negative 27x. We'll take away another 4 for negative 31x. Then we've got negative 27. Taking away another 3 will be negative 30. So we integrate it, increase all the powers by 1. We're going to have x to the power of 4 and divide by 4. X to the power of 3, divide by 3. X to the power of 2 and divide by 2. And we're going to have x. So unfortunately for this question, we haven't actually cancelled out and got any whole numbers like we did with the last one. Then we think about our substitution. Now we've got a slightly larger area and a very small area. And the intersections are at negative 2, negative 3, and negative 5. So area 1 is going to start at negative 5 and end at negative 3. So the largest one is negative 3. Substitute that first. Take away the smaller one, negative 5. And after all substitutions, you get the area of area 1. Now area 2 is also between negative 3, but it's between negative 2 as well. So the larger one of those is a negative 2. It should be a new substitution, but you should already know what the negative 3 substitution gives you from the previous question. And that'll give area 2. Add them together for the final answer for the area. And for this question, you should get 3.1 to 1 decimal place.